Hello students. We're going to finish off combinations tonight. We'll finish the counting, and the only lesson that I'm going to go over with you, or this lesson in particular, is just a few examples. One particular is called a case, but the others are just a bit of a review again to make sure that we're understanding the difference between a combination and a permutation, because that's a really big chunk of this unit, is that understanding. So like I said before, after this, it's just practice, practice, practice. So I'm going to go over just the first couple that are these number 1 and 2 on page 111 in your workbook. They're just a chance for us to, again, process this idea of a permutation combination and some different examples. So this first one is identifying whether it's a permutation or a combination. So I'm just going to go through these. I'll go a little bit slow. So if you want to do them and then kind of, it's a chance for you to check your own knowledge, or you can wait for me and go on along with me. So for the first one, appointing a chair, a vice chair, and a secretary from a committee of 9 students. So we're choosing 3. It's a committee. So then I'm thinking, is there a particular order to my committee? Is there a position involved in my committee? And since we have to have a chair, a vice chair, and a secretary, then there are positions, and so this makes it a permutation. And that's where we get this wording of order matters. If someone's a chair versus a vice chair, they're different, right? They have different responsibilities, all of that, so the order is important. Part B, though, choosing any 3 of 5 flavors from fruit juice. So if we had orange, strawberry, and kiwi fruit, well, if I switched up the order and did kiwi, orange, strawberry, it's the same 3 juices. Nobody has a particularly higher level, and so this is a combination. And then forming a sequence of plus cross symbols using 5 cross symbols and 4, or 5 plus symbols and 4 cross symbols. This one, we're actually going to place all of them. So this one is neither a permutation or a combination in specifics, but since we're forming a sequence of all of them, this is the factorial. So these are really 3 good examples of some of the strategies and the thinking that you're going to go through whenever you put all of this together. When do you do the factorial? Well, you do the factorial when you're arranging all items. Every single one. If you're choosing a subset, so that would be like you're arranging all the items in the set. If you're arranging a subset, you're choosing a subset, then you're either a permutation or a combination. And then that thinking of does order matter, does order not matter come in. Okay, so those are good ones. Number 2, we'll go through how many possibilities are there for a 5-digit combination using the digits from 0 to 9. 0 to 9 means that there are 10 digits in total. If each digit can be used many times. So many times this means that repetition is allowed. You're allowed to repeat digits. Versus in part B, it says if each digit can only be used once, no repetition. So these are 2 that you have to keep also straight in your mind, repetition versus no repetition, where we want to select 5 out of those 10. So, okay, I'm selecting a subset, so I might start thinking, is it a permutation or a combination? If you're not allowed to have repetition, then this is definitely a permutation. And I could go 10p5. Or I could think of it that I'm going to put down 5 slots and I'm going to think about the possibilities for each of those slots. These are the same. If you do this, and you think about the formula, this will produce this. So you can choose how you really think about that understanding, what makes sense in your mind. So if I go through the slots, the first time I have 10, then I have 9, 8, 7, and 6. Repetition was not allowed, which is why I decreased my number each time. And that ends up being 30,240 possibilities. So if I go back up to the repetition one now, I can't do 10P5, but I also can't do 10C5, because that's a totally different concept. So if the repetition, I'm going to think about the slots, putting the dashes down, and I'm going to think about, well, if I'm allowed to repeat, how many do I have available each time? And since I can repeat, it's just 10 each time. And that ends up being more than 1,000. Which should make sense, that if you're allowed to repeat something, right, you're not decreasing the amount each time, you're not decreasing the size of the set that you're choosing from, you should get a larger number. Okay, so then the very last one that I'm going to go over with you is called a case. And a case is, there were some of these in the last one that was in the last homework, but you can identify a case because of the words, the wording on this. And there's words that'll stand out to you. In this particular case, it says how many different 4-card hands containing at least one heart can be dealt to one person from a standard deck of playing cards. So that's the word that's a tip-off to say this is a case, at least. It becomes, you could think of it like it's an inequality. We're not saying that it has to be exactly a heart, one heart. We're saying there has to be at least one heart. So that means I have to think about different cases or different situations for this 4-card hand. Okay, so I know that there are 13 hearts, which means there are 39 other cards, non-hearts. I could even put just a heart, just to make it easy for myself to write. Okay, so I want to think about all the different ways that I can get a 4-card hand that has at least a heart. Well, at least means that you're going to have one heart or more, right? Okay, 4-card hands. So I'm going to lay them all out first, and then I'll figure out what the combinations are for each of those. It is cards, so I know it's a combination, right? Because the order doesn't matter, how you're either laying it out or holding it in your hand. So I am going to use a combination in the end, and I know that. Okay, if I have to have 4 cards in my hand, the first situation I'm going to think about is that I'm going to have one heart, but that means I have to have 3 non-hearts. But that's not the only possibility, because it's not exactly one heart. I could have 2 hearts and 2 non-hearts, but that's also still not the only possibility. I could have 3 hearts and 1 non-heart. I might go off the screen here, hopefully not. But that's still not the only possibility. I could have all 4 hearts and 0 non-hearts. So we think about the wording of the or, kind of gives a tip off of what we're going to do in the end, what arithmetic we're going to do. But I have to consider all of those scenarios because of this at least word. So some of the words that will stand out to you, I'll do this in a different color. So at least is a tip off that you're in a case. You might have at most, which then means that you're going to stay less than that. You might have no more than, no less than, you could have a maximum of, a minimum of. There's any word that is telling you that it's not exactly a certain amount, right? You have more than one possibility. I would highlight that word, make it stand out that we have a case. Okay, now you're just going to go through, after you kind of lay it out for yourself of these are all the situations, these are all the cases. Underneath it, I'm just going to use my combinations to figure out how many ways can I choose one heart, and then how many ways can I choose 3 non-hearts. So the wording here is I'm going to have a heart and 3 non-hearts. So the and part means that I'm going to multiply those 2 together, but the or means I'm going to add them up. Okay, so I know I have 13 hearts, and I'm going to choose one of them, and then I'm going to have 39 other non-hearts, and I'm going to choose 3 of them. And then I can set that up, do that for each of those. So 2 hearts, so I have 13. This time I'm going to choose 2, and out of the 39, I'm going to choose 2. So just keep yourself straight. That's why I lay it out there at the top so that I can see what I'm choosing. Then I have 13. I'm going to choose 3 hearts, and then 39, choose 1. And then the last time, the last scenario or case is I would have 13. I'm going to choose all 4 hearts. And out of the 39, I'm going to choose none. And you can put that in your calculator all in one line. You can do it in parts, whatever makes sense to you. It ends up being, just so you can check yourself, about 188,000 possible hands, over 188,000 possible hands that you could produce by having at least 1 heart dealt in a 4-card hand. So there are a couple in this set of homework that has the cases. They're actually put right at the front of your homework. So you can do those. I would do the cases and do a couple of these. Do the other, check your understanding. You can see I'm holding up your homework. And then following that is a part called permutations and combinations, putting it all together. That is, this is where all of the problems, they're all mixed around. There's no particular order to them in terms of how we will learn them. So it might be the fundamental counting principle. It might be just a factorial. It could be a combination, a permutation, repetition, no repetition. They're all mixed up. The answers are included, so you can check. I would skip number 16. I'll write that up here. Skip 16. It's more of an algebra-based problem that we didn't go through. But all of the other ones, you've seen similar questions. So hopefully when you see one, you can start that processing of, am I arranging all of the items? That's a factorial. Do I have a permutation where order matters? Do I have a combination where order doesn't matter? Do I have repeating objects? Do I have a case where I'm seeing that word maybe at least or at most? Okay, so give them a shot. Let me know if you have questions. Good luck.